Here we're being asked to compute the consumer and producer surplus based on these supply and demand functions. The first thing that we want to do, of course, is find the equilibrium. You'll recall from algebra that we can find the intersection of two curves by simply setting those two functions equal to each other. Then, in order to solve this equation, which, by the way, has two solutions, 10 and negative 20, all we have to do is a bunch of algebra from high school. Feel free to pause and analyze that to refresh your memory. Now, in this particular case, we got two solutions for x, but x being a negative number doesn't make a lot of sense given the fact that x represents the number of items available for sale, and so we'll disregard the negative one and assume that x equals 10 is where the equilibrium point occurs. Now, it turns out the equilibrium point is 10, 300. How did I get 300? I plugged 10 back into the supply function. Or maybe I plugged 10 into the demand function. Shouldn't it give me the same answer either way? After all, that's where the curves meet. And now that we know the equilibrium point, we can go about the business of finding the consumer and producer surplus. You'll remember from the lesson that the surpluses are the shaded areas in this diagram. So to get the consumer surplus, we'll integrate demand minus equilibrium price. This integral, if you do the work, which is not shown here, you'll get 666 2/3. It's worth pausing here and mentioning that it can be a little tedious doing these definite integrals. By definite, I mean there are numbers at the lower and upper limits of integration. These definite integrals can be a little tedious. They're not difficult, but they're annoying to have to calculate. So what I tend to do is use my graphing calculator. I have a Texas Instruments 83. Many students have a Texas Instruments 84. I'm not sure about the 84s, but on the 83, I hit the math key and choose option 9, and I get the function integrate option. You may want to explore that and maybe look at some YouTube videos on how to if you're confused. It's pretty basic. And you can get an integral, a definite integral anyways, without having to do all the annoying arithmetic. Anyways, that number there represents the consumer surplus, which I'll round to $666. Maybe should have rounded to $667, but it doesn't really matter. In regard to the producer surplus, same idea. We need the shaded region underneath the equilibrium price. And you could do that on a calculator. Or, to be honest, I didn't even bother doing this on a calculator because I got 500, by the way, but isn't this shaded area just a triangle? And haven't we known since, I don't know, 7th grade how to get the area of a triangle? So don't even feel like you need to use an integral or a graphing calculator here, but that area does turn out to be 500, which means we now have our producer surplus.